Welcome. We're going to be exploring the line of best fit and how we can write the equation for that in order to represent data. So here's our example problem. Over the summer, Trisha held a lemonade stand in her neighborhood, and she was diligent enough to record the daily high temperature each time that she had a lemonade stand and how many customers ordered from her on that day. So we're going to take this information that Trisha wrote down and we're going to go ahead and plot that on to the coordinate plane. So on 21 degrees, we had 6 customers. At 23 degrees, we had 7 customers. 26-degree day had 10 customers. On the 28-degree day, there were 9 customers. On the 27-degree day, she had 6 customers. On the 28-degree day, she had 8 customers. On a 31-degree day, she had 11 customers. And on a 30-degree day, 8 customers came to visit. Okay, so here's our information now about her lemonade stand. Now notice, these points do not all fall into a straight line. You can try to make the line of best fit for it and see where you might draw that to fit them the most. Sometimes you'll have points on that line, sometimes you won't. This one's probably a little bit off. You also probably want to have it represented with about half the points above and about half the points below. Looks like I might have a few too many points below. So maybe a better line of best fit might be this kind of an idea. And now again, this is just the best fit. My best fit line might look a little bit different than your best fit line based on where we draw them. But they should all follow pretty much the same general trend for what's going on there. Now, as to actually write the equation, you are going to have to use your graphing calculator to do this, because I can look at that line and I can try to pick out 2 points that I would use in order to make a slope formula available to us. But again, if my line is just a little bit off from your line, that's going to be different. So the graphing calculator is going to come in handy here for us to do this. Okay, so in our graphing calculator then, we're going to click our cursor into our first line of entries, and I need to add a table of values. So I go to the plus sign up above my entry points and I select the table. So I'm adding a table. In this table, I'm going to put all of the data entry points that I have. So the temperatures that I used as my independent variable are all going to go in for X, 21, 23, 26, 28, 27, 28, 31, and 30. And then all of my number of customer values that were the dependent variable go in for my Y. 6, 7, 10, 9, 6, 8, 11, and 8. Okay. And then I like to count them up 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Make sure that I didn't miss anything. And so I can see these points a little bit on my graph here, but if for some reason you aren't able to see those data points, and if you look really, really closely up above my little house icon, you can see one point sticking out there. You can use this plus sign magnifying glass that comes up in the margin of that row entry, and this is a zoom fit. It will automatically adjust the scale on your X and Y axis so that you can see all of the points that you need. Right? So I did that magnifying glass. Again, that was in the margin of my entry point, and that adjusts where I need to. Now, I do still have the option to zoom in or zoom out on that graph as I might see fit. But if you want to have a better viewpoint, the zoom fit, that's your plus sign magnifying glass in that margin, will set you up properly. So we can see these data points looking just like the data points that we had plotted manually, but we're going to get the calculator to create that line of best fit for us. So let's pause and remember, when we write the equation for a line, we are always going to be writing that equation as y equals mx plus b. This is always what we do to write the equation of a line. So we're going to be thinking in terms of this when we go ahead and get our graphing calculator to do some work. There's just a couple of changes that we have to make. Notice the headers on your table are called X1 and Y1. That's an adjustment that we have to make. Instead of using just a plain old Y, we have to use the Y1 so that the calculator knows where to pull from. Instead of using just an X, we have to use the X1 so that the calculator knows that's where to pull from. Okay, so Y becomes a Y sub 1 and X becomes an X sub 1. We keep that M, we keep that plus B. The other change that you're going to make here, instead of using the equal sign, we are going to use the tilde or the squiggle. This is on your keyboard in the top left corner next to the number 1, and that's how your Desmos calculator knows that you want to do a regression. So leave my table in there. I go down to my second row of entry, get my cursor ready, and I type in this expression as we want it to make this regression. So y, and then I just press the number 1 immediately after it. Desmos is smart enough that it bumps that down to a subscript for us. And it's telling me right now that I have an 8-element list. That's correct. If you remember, we counted that there were 8 things we had to put in. And I keep on typing. I put that tilde in with my squiggle symbol, then M. For the X1, I type X immediately followed by number 1, and it drops down. Finish off that equation with the plus B. So when I have typed that in, you can now see there's a line coming up on my screen. This is the calculator's representation for that line of best fit. And you can see it's a little bit different than mine. My line I had going below both of those 2 points that were farthest on the left. This representation has the line going almost directly through, maybe in between those 2 points that are farthest on the left. So I was close, but obviously a little bit off. Now, what good does this do us? As you look farther down on that row entry where you put your Y1 squiggle MX1 plus B, it gives you some statistics information. The R2 value tells you how good of a representation this is. When R2 is closer to 1, it's a really, really good representation. When R2 is closer to 0, it's not as strong of a representation. So we've got R2 as a 0.4 here. That's not a very strong representation. This is just moderate. But we can write the equation of our line based on the parameters that are in here. It gives me an M and it gives me a B. What do you think those stand for? Yeah, the M is the slope, like we've always known it to be. So M would be the coefficient on X. B is the y-intercept. And so that's our constant in the equation. So you use this M and this B value. Usually we round it off to the hundredths so that we have 2 decimal places in there, and we fill them in. Okay? So just like in the equation of any line, we keep that y, use our equals. The M becomes 0.34, right out of my parameters, 0.342767. I only need to have it to the hundredths. So that was my 4. 2 behind it says to keep it the same. Then I go ahead and put my X in plus my B value, and look at that B. Oh, it's actually a negative, so we don't want to add that B value on. We're going to subtract it, and a negative 1.04. The next digit is a 4 again, so that doesn't tell me to round up. I'll stay the same, 1.04. So this is the equation for our line of best fit. This is the equation that I would use. I would type into the graphing calculator if I wanted to create this black line that's shown here to represent me and all of those points. You can do this for any set of data. You create a table, type in your X's and Y's, and then it is always this Y1 squiggle MX1 plus B. This is your formula to make the graphing calculator write the equation for that line of best fit. It will give you your M and B value so that you can plug your M and B into the equation. Hope you're having lots of luck with this.